Hi, my name's Waleed. I'm the head of engineering here at Anyscale, and I'm really excited to talk to you today about the combination of LangChain and Ray. What we'll be talking about today is showing you why LangChain is such an awesome library and why it's so popular within the large language model community. And then I'll show you a little bit about how Ray complements LangChain by allowing you to build indexes more quickly, serving LangChain on the web directly, and allowing you to put models and the serving in the same place to keep latency nice and low. So let's imagine now that I'm trying to build a search application. And this is part one of three parts that we're going to have. Part one is this part where I'm just going to build like a little search engine. In part two, we'll look at enhancing that to use large language models to summarize those findings. But really, just even doing these basic things with the search engine shows what's possible. So imagine that I'm trying to make docs.ray.io more accessible. Well, the first thing that I can do is I can use the power of large language models to create a really nice semantic search engine that isn't just finding words, but is actually finding meaning. And we're going to talk through how we do this in a moment. But it's really exciting just how easy this is. I remember when you wanted to build a search engine, you used to need lots of machines and lots of organizing, and you still wouldn't get great results. It's just amazing to me how LangChain makes this easy. So the process that we're going to go through is essentially that we're going to start with our docs.ray.io website, just scraped it. We're going to load the files into memory, and then each page we're going to divide into little chunks. And it turns out that this is going to generate about 48,000 sentences. So each page, you can imagine breaking it up into sentences. It's not exactly sentences. They might be slightly longer, slightly shorter. Then we're going to use this sentence transformer that Hugging Face makes available to project every sentence into a 768 long vector. This process of taking a sentence and converting it to a long vector is called embedding. And so we're going to take those that row, and then we're going to store them in an index. And so once you have the index, that allows us to then find the information. So I'm now going to go to our code and walk you through it. It shouldn't take very long. The first thing we're going to do is just look at how easy LangChain makes this. So we're going to go here, and we're going to specify where the index is going to go. This is all that I need to specify with LangChain to pull all the docs into memory. And then I define a very simple text splitter here that takes all of those pages and cuts them into little pieces. And so, sure enough, we load these documents, and we create the documents from them, making sure to keep our metadata. So all we're doing here is we're generating the chunks using the metadata. And then the final stage is for each of these individual little chunks, we're going to embed them in the space, put them in Face, which is a good vector store, and then we're going to save it locally. Now, we used Face, but LangChain actually supports a huge variety of different systems. All right, so this works really great. The only issue is it takes a few minutes. Now, obviously here, docs.ray.io is not very large. It's about 130 megabytes. But having something this slow operate at scale could be an issue. And this is where the power of Ray and LangChain together becomes really impressive. So what I'm going to do here is I'm going to switch over to my Jupyter lab. I'm going to clear the screen. And we're going to start a process here. While it's running, I'll come back and discuss what that process is doing. So what we're going to do here is the first part of the pipeline is exactly the same. But then what we're going to do is split that effort into 8 different shards. We're going to do those embedding process, which can be quite GPU intensive, using 8 GPUs at once. And then finally, we're going to combine them into a single merged database that we're going to push to the Face index. And as you can see, it's running very nicely here. It's still loading the documents. So it's loaded the documents into memory. And now we've constructed those 8 different shards. And now each one of those 8 shards is processing the data at once. So now you can see that there are 48,000 documents or so. Each one of the shards is processing the data. And you can see that now they're loading the embeddings from to disk, but it's doing it once on each GPU. And we can start to see that here if we go look at the cluster. So as you can see, those GPUs are looking really hot. They're now chunking away trying to do this data. This is a machine with 8 GPUs. And so you can see all of those are working really hard. And now, very quickly, you can see it finishes the work. And that process is now complete. Some of the shards are finished, some take slightly longer. But from taking 5 or 6 minutes, it's now completely solved. So that's an example of how you can use Ray to speed things up. All right, let's go back. So now that we have our index, how can we serve it? And this is really, again, one of those instances where Ray can really help you to do something without it being much effort. So what we have here is that the request comes in, and it's usually just a sentence that we'll see. We transform that one sentence into a vector, just like before, using the power of embeddings. And then we're going to try to find a set of 4 most relevant sentences, or 4 sentences that help the user understand, and return a response. Now, let me just have a look at the source code for that. So what we can do here is just show how easy this is. As you can see here, all that we're doing is we add an annotation for serve deployment. In the beginning, we load the database and we load our embeddings. And then when the query comes in, we simply do a self.search result here. This gets the maximum marginal relevance and then just does some nice nice processing. All we need to do to start the deployment and go through the code that we put together is just have a command that looks like this. It names the file that we're going to use and has the vector stored, and it just names the deployment that we've created. Sure enough, it's starting up now. It might take a few minutes because it's packaging up everything to make it ready for serving. And now the moment of truth. We've written a very small program here called query.py that simply takes a request at the command line and sends it to the web page that we've just loaded. So let's see how that works. I'm going to simply ask the engine, does Ray Serve support batching? And sure enough, when we hit that, it hits a number of web pages that show you exactly where you need the information about Ray Serve's support for batching. Thank you very much, folks. I hope you see now why I'm so excited about the combination of LangChain and Ray. If you want to find out more, please come to Anyscale.com, and there's a lot of information there that you can find to do this, as well as a blog post that has this information with links to actual code. And look forward to talking to you next time.